Hi, let's discuss the solution of the given question. Here, what is the given question? If x greater than y greater than z, then find the value of cot inverse of xy plus 1 by x minus y plus cot inverse of yz plus 1 by y minus z plus cot inverse of zx plus 1 by z minus x. Here, our task is to evaluate this expression. First, let me write the given expression and then we will think about the solution. Given expression, cot inverse, each term contains inverse cot inverse xy plus 1 by x minus y plus cot inverse yz plus 1 by y minus z. Right, third term cot inverse of zx plus 1 by z minus x here. Clearly, in each and every term there is a cot inverse. Suppose if I am able to write cot inverse in terms of tan inverse, then easily I can apply any standard formula. Here already we have one formula, tan inverse in terms of cot inverse. Let me write this side. What is that formula? Very important formula. Tan inverse of x, which is equals to cot inverse of x when x greater than 0. When x greater than 0. But when x less than 0, there is a formula, there is a another result, that is minus 5 plus cot inverse of x when x less than 0. This is the standard result in inverse trigonometric functions. Now we will apply. See, here already there is a cot inverse of x. Suppose if you observe on RHS side, there is a cot inverse of x. When you have cot inverse of x, simply you can write tan inverse of 1 by x. But keep in mind, there is a constraint x. You have to cross check every moment whether x greater than 0 or not. Or whether if x is greater than 0, then you have to apply cot inverse of x. Or else if x is less than 0, you have to adopt this one. See, first in the first term, second term, third term, we will check it. Here cot inverse of x means here the entire thing comes into the picture. There is a fraction. What is that? xy plus 1 by x minus y. Here simply given that already. What is that? X greater than y greater than z clearly. See here in the denominator there is a x minus y. If x greater than y, simply already numerator is positive. See, if x greater than y, denominator is also positive. So the entire thing, the entire value means xy plus 1 by x minus y greater than 0. See, simply there is no issue here. Here also y greater than z. Already they have given y greater than 0. So y minus z is always greater than 0. Already numerator is greater than 0. This is also greater than 0. But here zx plus 1 by z minus x. See, x greater than z. From the given relation x greater than z. So simply z minus x is a less than 0. So you have to adapt the second result. Means minus by plus cot inverse of x. The rest of the things you can adopt first one, that is cot inverse of x. Now I will write. In the next step, which is equals to here cot inverse of x means tan inverse of, see here this is not x, 1 by x. Here I spelled 1 by x only. Here cot inverse of x means you have to write tan inverse of 1 by x. See, in the next step, tan inverse of, here x is xy plus 1 by x minus y. But I want 1 by x means you have to take reciprocal of this fraction. That is x minus y by xy plus 1. So plus second term also you can write easily tan inverse of, what is that? Y minus z by yz plus 1. But for third term you have to adopt the second result. But I want minus pi. You can add pi and at the same time you can subtract. So minus pi plus cot inverse of x means tan inverse of z minus x by zx plus 1. At the same time there is a plus pi. Let me write that also. Here directly I am writing instead of writing one more step. See, what is that? Tan inverse of z minus x by zx plus 1 plus pi is there, keep in mind. Why? Because I took minus pi and at the same time added one more pi. See, then the system is going to balance the expression. That means in the next step, here there is a standard formula in inverse trigonometric function. What is that? There is a tan inverse of x minus y by x plus xy plus 1 is there. There is a formula. What is that? Let me write here. Tan inverse of x minus tan inverse of y, which is equals to tan inverse of x minus y by 1 plus xy. This is the formula. Simply you can adopt this formula, you can apply here, finally we will get the result. Now in the next step, tan inverse of x minus y by xy 1 plus xy means xy plus 1 or 1 plus xy both are same. See, which is equals to tan in first term can be written as tan inverse of x minus tan inverse of y. X tan minus tan inverse of y simply. Similarly for the second term also, here let me write here tan inverse of y minus tan inverse of z. Next plus here for third term also tan inverse of z minus tan inverse of x. Already there is a plus pi. So in the next step, which is equals to, here suppose if you observe in this step, tan inverse of x is there, minus tan inverse of x is there. So both are gets cancelled. Next minus tan inverse y plus tan inverse y. Next tan inverse z plus tan, minus tan inverse of z plus tan inverse of z. Finally all terms are gets cancelled except pi. So which is equals to pi. See, this is the required conclusion. Finally we got cot inverse of xy plus 1 by x minus y plus cot inverse of yz plus 1 by y minus z plus cot inverse of zx plus 1 by z minus x equals to pi. So this is the final conclusion. At last, what is the key concept we applied here? Simply we applied two formulas. What are those here? First one is tan inverse of 1 by x equals to cot inverse of x when x greater than 0 and minus y plus cot inverse of x when x less than 0, and one more formula, there is a standard formula tan inverse of x minus tan inverse of y equals to tan inverse of x minus y by 1 plus xy. Thanks for watching. All the best.